So, good morning. It's not lunchtime yet. My name is Matti Flinckman from Växjö University, Department of Forest and Wood Technology. For the moment I'm teaching quite a lot, but I have also background in market research. Flinckman sounds very Swedish. With two N it sounds German, and Matti sounds very Finnish. So I start this presentation in English, use some Swedish words, and at the end maybe I speak just Finnish. But I have some slides here to show. Okay, I hope you can see these font sizes. I have two titles here. The first one, Market Potential and Life Cycle Analysis of Massive Wood Buildings. It's in the program, and you can also see that my colleague, Professor Anders Paudin from Växjö University, should have been here, but unfortunately he couldn't do it. So he asked me to give this presentation, which is based on EU-funded project Sustainable Energy Systems in Advanced Cities. And this output is one working package. The other title, it's the title of the output report, Prospect for Timber Frame in Multi-Story House Building in 6 different countries in Europe. And it's written by another colleague to me, Ragnar Jonsson. And both of them are now working, I think they are in Italy, in Padova, preparing next UN Timber Committee work. So, therefore, I'm here today. And, of course, this timber frame construction is, for me, quite clear that it is an important topic on this kind of eco-building conference. Of course, you may have, and you have already get several views why it's important, but our starting point is this one. Computer, okay. Nothing happens. So, our starting point is the fact that the construction sector uses about 40% of the total energy consumption in the world, and is responsible for 30% of the total emissions. And in this context, when we are talking on the global agenda, climate change and energy issues, so construction sector plays a big role. If it can reduce energy consumption and emissions to the air. And as you know, if you use wood, there are many advantages. And not only in the construction phase, it's given here as in use phase. It said that timber system is more cost effective, and it also have many other positive aspects, of course. But I think we have to consider this in the wider perspective. And I'm a forester also, and I start from the very beginning, from the forest, when we tried to create this raw material. And if you just forget that this conference is about construction, imagine that you are foresters instead. So you are growing forest, and in the beginning you plant the plant, and very soon you have a very fast-growing forest. And during this phase, the forest is catching carbon. And when it's getting older, this carbon catchment is becoming less and less, and at the end of the lifetime of the forest will release carbon again. So in the beginning it acts as a carbon sink, and at the end it's releasing carbon. So if we just are dealing with forestry, we can say that forests are carbon dioxide neutrals. It's like with fishing, you know this term, catch and release. Forests are doing the same thing. And if we then do, as we do here today in the Nordic countries quite a lot, we use wood as a raw material in construction, it means that we catch carbon and keep it in storage quite many years. And at the end, when we have to, at the end of the lifetime of these construction houses, we may reuse materials, or even if we burn it, it means that seen over the whole lifetime, we have a carbon dioxide neutral system. Okay. So this is the topic for us for this study, to figure out the market share of multi-timber framed houses in different countries and make some projections on that. And I'm also a market researcher, as I told, and very often we are working with econometric or statistical models where we try to explain some phenomenon. For example, the market share of timber frame using some kind of explaining factors. And usually we have economic development as the most important regarding all kind of house building. And also demographics are important. It means population, if it's increasing or decreasing. The size of household, the number of household, and the age structure of population. They all have an impact on construction demand. And if we are introducing new products, as here, this timber frame, it's important to figure out attitudes, values of people. And in the short run, of course, it's so that those who are most engaged in construction activities, architects, developers, and construction firms, they have the biggest impact. But in the long run, it's of course you and I as consumers, our values and attitudes and wishes and so on, and they in turn influence building regulations and even other policy measures. And what I'm going to do here is to show some overall determinants. And then I give some kind of country-wise review of our results regarding attitudes, policy measures, the state of the art, and some projections. This is not econometric study, but anyway, I think these factors can explain quite a lot. So I start with GDP growth in different countries, in these 6 countries. And it's 5 years averages. The first one, 95, 2000, 2005, 2010, which is updated very recently. And then we have 2015 and 20. And it's not so easy to figure out what is going on. But if you look France and Germany, the 2 here above, you can see that they are on the level a little bit below 2% over the whole period, more or less. Then we have in the bottom the Netherlands and Sweden. And they are somewhere in the middle, over 2% over the years. But in fact, there are no big changes. And then we have Ireland, which has experienced quite high growth, and it will come up to quite high in the 2020s. And then we have UK, which is a little bit below here. So I think there are no dramatic changes except this slowdown we are experiencing at the moment. The next is about population. And if we start with France, about 60 million people, 2005, growing a little bit, it means about, it could be 6-7%. Germany will get less people. UK has almost the same level with France and the same growth, maybe 6-7%. Ireland, in turn, a small nation, it's almost up to 20% over the period. Netherlands, 16 up to 17. It means, let's say, 6-7%. And Sweden, up to 10. And it is also quite large growth. But what is interesting here, in Sweden, you know, we use in country about 6 million cubic meters sawnwood. If we compare with Germany, what do you think is the level in Germany? Use of sawnwood. 9 by 9, 82, 81. Some who want to guess, make a guess? No, it's between 15 and 20 million cubic meters. All sawnwood. Not just in construction, also in civil engineering and packaging. And so, just an example. So the next one, and you shouldn't see this kind of pictures, but the main thing is that we get more small household in every country. And for example, 2004, Sweden had 46% one-person households. Germany had 29, UK 31. Are Swedes lonely people? They have no pubs as in England. Anyway, it's important to realize also that this is not the whole truth. It's also the question of who are those lonely people? Are they elderly people or young people? So this will have an impact of the demand of construction activities. Here we have some figures of aging population. And, oh, excuse me. 2008, if you look this column, all these countries are in the range of 20-30%. It means 30% of the population is older than 65 years. In 2030, the forecast is that in every country, more than 30%, or up to 40%. Germany, 46% of the population are older than 65. Maybe it's an idea for me to emigrate to Ireland. Maybe they would take care of me better there. There will be the lowest rate for old people in 2030. So now I will go through all these country-wise results. And yes. I make some jumps here. Yes. Time is running away. Okay. It's almost in every country so that people, important things for the people are location, affordability, safety, comfort, and so on, in every country. In England, there is some concerns about the quality of timber frame, but in Scotland, the reputation is much better. And therefore, and then we can look some policy measures. Up to 1991, it was allowed to build 3-story houses with timber frame, and they needed some kind of special waivers. From 91, it was allowed to build 8-story houses. And there are some other policy measures going on, the most important being this, the wood for good. And I think this is the most important for the results in UK. From 1998 to 2007, the share of timber frame have increased in England from some percent up to 15, and in whole Great Britain up to 20, and Scotland included here. And it's believed that the market share of timber frame in England will be 25–30% within 10 years. And of those multi-story houses, about 40% will be built by timber frame. And France, there is no cultural references for this kind of building. It's not used in French building traditions. And they have also quite many policy measures here going on with quite bad impact on housing. I can say that for multifamily dwelling starts, the timber frame share was only 1%, 2006. So it's very low, and depending on cultural barriers. Germany, there is very large regional differences. In the southern part of Germany, we are using timber frame very much, but mostly in single family houses. And they have also a number of policy instruments. It's allowed to build up to 5 stories today, and there are many goals to reach higher levels, and it's believed that they will increase from 14 to 30% in 1 and 2 family houses, and maybe up to 10% in multifamily houses. And Ireland, in turn, there's big confidence for this kind of construction types, and it's the fastest growing method here. And they have this kind of policy instruments. It's allowed to build up to 4 stories. And there are quite recently new regulation from July 2008. And this might be more interesting. In the beginning of the 90s, timber frame accounted just for 5%. Now it's up to 30%. And it's, of course, depending on the structure of construction in the country. Private housing counts for 90%, and about 80% of the dwellings are single family. So we can compare with the Swedish conditions here. And they are very hopeful. They think that within the next decades, the level of 50% will be reached. Okay, and the Netherlands, it's like France. There is no tradition in this kind of building concept, even if they have had some programs for this with targets up to 20%, but the outcome is 16%. But the reality is that if you look here, the market share in residential, commercial, and industrial construction was only 3% in 1998. And there has not happened much after that. But they should have much more concerns if we think that this climate change and the level of sea is rising and so on. So they will get big problems. And Sweden. I think you have heard quite a lot of Sweden. Wood was panned about 120 years in Sweden for the construction in more than 3-story houses. So it has had very big influence on our activities. And we have, this is the most recent policy measurement, national wood building strategy, which is supporting architects and construction engineering and education. So I jump to the conclusions here. The main problem for us has been that there is no data on timber frame in multi-story houses. And we can also say that these countries are in different evolutionary stages. France and Netherlands are in the introductory phase. England and Ireland are experiencing very good development. Germany in the southern parts is expecting quite a big growth, and Sweden also, I think so. And the conclusions of this study is that we need comprehensive communication and feedback in order to learn more. And we have to rationalize the on-site processes and come away from the craft-based approach towards multitasking. And we have to develop industrial standards and norms and other policy measures, and even more greater involvement of construction firms. And at the end, I think the most important thing is that we, consumers, have our values and try to proceed these things. Thank you.
Thank you very much, Matti. This is really about awareness, isn't it? I think it's very, very interesting. Imagine if we in 30 years or something be able to look back this at sort of a breaking point where we started taking timber, because timber has for centuries been the normal way of building things. The concrete and the steel area it's still quite young. Maybe if we can sort of make a shift and being able to look backwards, I think it would be very, very interesting. Before we move away with more awareness and how that can affect your energy consumption, do we have one question for Matti? Okay, then I would again say thank you very much.
Thank you very much.
Take care.
Thank you.
Then I will invite you up.
I just want to say that there is some examples of this report on the desk.
Tjena, nu ska vi se. Flicka.
Den berör
Framåt med
framåt, men nedåtgående och det är en paus.
Okej. Hi everyone, last presentation before lunch, so I'm going to try to keep on schedule. My name is Johan Saltin, and I come from the local energy company here in Växjö, Växjö Energibeteende. And I'm going to talk to you about how it's possible to change people's energy behavior so that we can save more energy. And I'm going to present the results from 3 projects that we have performed and are performing. All of them involve different ways of visualizing the energy consumption and using that visualization to change the behavior of how people use energy. The first project, which is part of a young energy program in Sweden, tried to engage the youth in which are the most powerful group in our society because they affect the big families, and try to engage them in saving energy. The second and third project are 2 projects that's part of the SESAC program. The first one focuses on changing the behavior in the apartment or the apartment houses. And the second one is on the city-wide scale, changing the energy behavior in Växjö. As I told you, it's 3 different methods of visualizing the energy. In the first one, we use a cell phone. In the second one, we have tried and developed different methods of seeing the energy consumption on displays in the apartments. And in the third one, we have developed a web-based system, which can be used by all the users of the energy services in Växjö. So in the first project, we, together with some other energy companies, developed methods for a competition between youths around Sweden. And what we did there was to connect cell phones applications with the energy measurements in their homes, and trying to get them to save as much energy as possible. Oops. And via the cell phone, they were able to see their daily consumption. They were able to get some results from the competitions or their competitors, and also some advice on how to change the energy consumption in the household. And this was a fairly successful project. The best group actually achieved 37% savings in electricity consumption. In the second project, which is an ongoing project, we have installed displays inside apartments for individual metering of electricity, hot water, cold water, for the apartment owners, so they can see how their behavior actually affect their usage. What we have also done in this project is to find a method of changing the behavior. So not just displaying, we're actually doing a big process of increasing the awareness about energy behavior and things like that. So this is an example of displays that we're using, where they can see the hot and cold water consumption, the electricity, and also in some case the heating demand. But this is installed in the apartments that Emmanuel was talking about earlier. So we don't have a lot of heating demands there, since it's low energy housing. What we have done is we want to see if we actually achieve a change here. So we have taken a couple of reference apartments around Växjö where we don't have any measurement devices or displays. And we have also some apartments where we have the displays only, and also apartments where we have the displays and also the demand, the whole methodology for changing the awareness of energy consumption. So we're going to see how these things affect the consumption. To be able to do this, we developed a theory on how we could actually affect the energy consumption and how to go about it. The first step is when the new owners of the apartment actually start thinking about moving into an apartment. Then we, together with the housing company, give a lot of information about the low energy consumption in these apartments, how they can change the cost of their living by decreasing the energy consumption, and all that kind of information. And then in the second phase, during the actual contract writing, they can see the apartment, they can also look at the functions which are built into the apartment, and they also get more information. And the awareness increases, and hopefully the ability to decrease the energy consumption. In the third phase, when they actually move into the apartment, they get a thorough explanation of how to work with the system, and also how to live in the apartment in an energy-wise manner. And they also get the tasks that they should perform, like go in and take a short relaxing shower, and then go and check how much energy they consume during that task. And then as they go on living in the apartment, in step 4 they get feedback on their energy consumption, and they also get comparisons with other apartments in the same house. We start to engage them in games or activities where they try to be the most efficient apartment in the house and things like that, and try to increase their awareness during the whole process. And then finally in the part 5 there, they should be very positive about this and start going on with it and taking into new methods of decreasing the energy consumption and things like that. So this is our theory on how it should go about. And to do this practically, we developed a 10-step process, which include information, both on the apartment and on the information system, or the measurement system. We also gave them different ways of changing the energy consumption. Information leaflets when they moved in, and during the process when they were living there. And then after a while we started surveys or did surveys on how they thought about living here, what they could improve and things like that. And all the time giving them feedback on the results of their energy consumption and the surveys that we perform. And then finally giving them more detailed information on climate change and human behavior and things like that. And the last possibility is to actually send out text messages into this display on if you do this, you can change the energy consumption like that. So we have done this now on 26 apartments and done some measurements and seen some results. So if we look here, we have the hot water consumption. In this case, the reference apartments, they don't pay for the hot water. It's included in the rent. In our apartments, they pay for the hot water consumption. So what we see here is that they actually get the information about how much they consume, and they also pay for it. So that's probably both effects for decreasing the consumption. And we don't see our information campaign here, or the demand side information. It doesn't affect we don't see any difference between the reference departments with only display and the reference departments with the whole process of information and getting the awareness up. So it's essentially mainly displaying and paying for the energy. Now the problem here is this is just initial. We're not sure if this is an ongoing effect that we will see, because after a while people get used to paying for the energy, so it might be that the hot water will increase here. But since the project is ongoing, we'll see the long-term effects as well. However, if we looked at the electricity consumption, we see a different thing. Both the display and the display and campaign apartments show a lower level than the reference apartments. But we also see here that by performing the actual active work as well, engaging the apartment owners in their living, give some increased savings. So 34% decreased electricity compared with 24% for just having the display on the actual consumption. This shows another comparison of the same results, where we also see that there are new apartments, they are smaller than the actual apartments, or the reference apartments, which could also have some effect into this, because we might have bigger households in the reference apartments as well. But this is something that we will investigate further in the studies. But the biggest effect we see on the electricity and on the hot water consumption. As I told you, we're continuing this work, and we're installing the displays in another 222 apartments. Actually, they have been installed, but now we're in the process of working through this curve with these apartments and evaluating the results from this. But initially, the results are looking very good. So this methodology that we have worked out with the demand side management, information during the searching for the apartment, during contract building or contract writing, giving information and also showing the possibilities with the apartments and the measurement system and the billing system as well, since you actually affect your own consumption and only pay for what you use. And then further information and actual task to do when you move in. And then the whole process during the time you live in the apartment, with feedback from your consumption, comparison with other apartments, doing activities like being the most energy efficient apartment and things like that. And also getting information about other possibilities of changing the energy demand. For instance, we have started to include small advice on the billing every month. Like in November, it will be wash your hands in cold water. It might actually feel nice or something like that. And then turn off the water while shaving and brushing your teeth. That's just to point out some extra things that they can do. Now we have found this method and seen that it can actually affect the electricity consumption. Now we want, and that's been done in apartment houses. Now we want to take it to the city level and see if we can do any change on a larger scale. And we want to actually do something, a change here in Växjö. It might not be a very big step, but many small steps that can actually give some large change. So, and also if we're able to do it here in Växjö, we might be able to do it in the rest of Europe as well. The first problem is that we need some way of actually displaying or visualizing the energy consumption in the households around Växjö and also in the bigger corporate consumers and things like that. We already have installed, or we have installed during the time here, measurement systems for electricity, district heating, and cold water. So we have those data in the company. So we only need to find a way of actually visualizing this. And to do that, we have, together with a company, developed a web-based system that's called Energikontor. And it makes it possible to see your actual consumption from day to day for hot water, district heating if you have that, cold water, and electricity. And you can also see how much or how you compare to the month before, and also on what kind of level you are, if you're a normal consumer or a high-end consumer. So you can actually compare with other parts of Växjö or other consumers in Växjö. And depending on how you behave on this scale here, you also get some pop-up messages here on if you're a very good consumer or if you're using too much and things like that. So it's a way of actually getting some feedback on your consumption, and you can check it every day. Other ways of using this system is that we can actually perform games or between city blocks inside Växjö, or inside the whole Växjö, or between different apartments or different houses in Växjö. And this makes it possible for people to start to discuss the way they change the energy consumption and things like that. And this tool actually got awarded by the European Utility Award in 2007, I mean. So winner of the 2007 Customer Excellence Award. So something that we're very proud of. Now we have this tool. Now we just need to engage the people in Växjö. So together with the Växjö City and the Växjö housing companies like Växjöhem and Hyresbostäder, we have started this SAMS campaign. where the goal is to save 5% of electricity in the households in Växjö, and to affect all 56,000 inhabitants inside this region. And by doing this, we can save a lot of CO2 at a low cost. And what you see here on the display is the actual map of energy consumption around, or electricity consumption around Växjö, where the different colors give different amount of consumption in different areas. So the red ones are using a lot of electric energy, and the blue ones are using small amounts of electric energy. Oops. Oh, last one, sorry. So what we have seen is that by actually making people aware of the consumption, or the energy consumption, we have a great potential of reducing the energy consumption. So that was my presentation.
Thank you very much, Johan. At least I hope there was more people than me who kind of feel a little bit impressed. Because, of course, we need technical innovation, we need innovative cooperation, we need a lot. But we have been talking ever since this morning about awareness. Awareness of possibilities, awareness of contract, construction methods. This is when the awareness really comes to the tenants. And a proactive utility company providing this information, I think it's very, very thrilling to see this developing. But I would also like to see what will happen in 5 or 10 years. It's the real challenge.
Yeah.
It's the real challenge. Is there any more questions for Johan? Yes. Excuse us, you will have to loud.
Was there any resentment of the people in the houses where you put your equipment to measure?
No, these were new houses, so it was part of actually the apartment when they moved into that. So we didn't put in the displays in existing houses. So they were aware of it during the whole process, from information about the apartment, contract writing, and everything like that.
There's a lot of resentment against the smart measurement methods of energy. But these were new houses. Okay, thank you.
The resentment in Holland was based on the fact that these systems were proposed by the electricity system by companies. And the effect and the target of those systems was aimed at providing information for the energy companies and not for the users. That was only secondary. Yeah. And it got to a stage where the Dutch government almost made it mandatory that those smart metering systems were introduced. And that was stopped recently by Parliament because of privacy reasons. And so the question basically is more, well, how did people react to having this in their house? Was the reaction positive, or was it neutral?
The displays, I don't think, because it's only 29 apartments to start with, and that we've done it, and it's 200 now. The bigger thing is the information that we do via this Energikontor, where we actually measure the district heating consumption and the electricity consumption. The electricity is no problem because it's mandatory in Sweden. So every distributor and producer of electricity needs to have it in the household. And also we've had this information for a long time. So the only thing we've done now is to make it usable for the consumers. So I haven't seen any negative.
There are similar examples in Holland where the systems were really based on use for the owner, mainly based on private systems. There is a small independent kit available which builds up a mesh network in your house, and it's only developed for your own use. And the reactions on that system are very, very positive. But that's the people who want to have a system like that. So it's not
a reference group.
I think we had one final question down there.
Thank you for a good presentation, John. One question in two parts. In choosing the smart meters and the displays, is there some information perhaps later, if it's too detailed, to go through that choice? Did you have a lot of different types of displays and smart meters to choose from, and how did you come up with the one that you ended up using? And do you have many different types?
Yeah, we have tried different ones, and we have come up with one that's working.
Okay, I'm certainly interested perhaps later to find out which one that is. And the second question I have is, have you deployed this in Växjö University at all? Have you tried this with university students or schools as opposed to housing?
The young energy thing with the cell phones, that was used by the 7 to 9 grade in Växjö and other cities, where they use the cell phones and try to compete with lowering the household electricity consumption. But we haven't done anything specific on the universities yet. No.
We have done experiments about it, and did an example of data on the winner. This was a very short period trial, about 65% reduction. And the average was lower than your figure was 27.
Yeah. We did a short-term competition between politicians and managers at the energy company, and I think 65% was the lowest there as well. But that essentially meant closing down refrigerators and everything, and yeah. So.
You can really make a difference.
Yeah, you can.
I think there is a lot of interest. We take two more questions. The distinguished gentleman in the red tie. Yes.
Regarding CO2 emissions, the transport is the most important. Have you discussed also that the customers could give in input with the transport use in the families and so on? Because that could be very interesting to develop.
To develop metering systems for the cars?
No, not metering system, but they could introduce and put in the figures by themselves, maybe.
Yeah, okay. No, we haven't discussed that, but that could probably be done.
Okay.
Yeah.
Behind you, Sara.
Well, you are an energy company, you sell energy. Why do you help your customers to buy less from you?
We're part of the greenest city in Europe. and the electricity doesn't have any boundaries. If we don't use it here, we'll sell it somewhere else. So.
Does that also mean that you are pro-passive houses?
Yeah, we personally I am.
We are approaching lunch. We take the final question.
You actually shown a quite dramatic figure. I don't think everybody will be aware of what you've shown, but you've shown a figure that the reduction result by working on the behavior has cost in these tests 1,350. On the 1,350 ton annually reduction would cost 100,000 euros. Calculating back, that means 80 euros per ton reduction. A similar investment in insulation would be in the region of 1,000 euros per ton. Similar investment in improvement of efficiency of systems costs in the region of 5,000 to 10,000 euros per ton. And if we get to the improvement of fairly high standards in new build and get that to, for instance, regions of passive, that's even higher than that.
Yeah.
Why are we actually bothering about trying to work with techniques? Why don't we all start with people? And why hasn't that been the message yet, which everybody's working on?
It's a first step, but it's difficult to change
you're
behaviors.
showing 35% reduction possibility for less than 10% or closer to 5% of the cost.
Yeah, but what we have achieved so far is 1% in this project, and that's equal to one light bulb change for each person in Växjö.
Yeah, but that only shows that there's not yet much result.
No.
But the cost benefit ratio
is very high,
massive compared to other things that everybody's working on.
Yeah, but the normal thing for human people is that we are lazy. It's difficult to change. So, but it doesn't cost much.
Yeah. And I think a good response is we can do both, and maybe by have the environment, the behavior changes as some of the very low-hanging fruits. You can actually use them to co-finance some of the more costly technical investments that we do need to implement anyway. But it's, as I said, it's thrilling. It's very, very interesting. Thank you very much, Johan. Thank you very much for this morning session. So if you just take the tour, the lunch is served over here. Thank you very much.